Good afternoon, everyone, and welcome to our final lesson of the year. This is 4.4. It's called Miles of Emissions, Systems of Linear Inequalities. So we've talked about systems before. Systems were two equations. So in this lesson, we are going to be doing two inequalities. It says Jared's family determines that on average they drive their SUV more than twice as many miles as they drive their car. Jared writes the inequality S is greater than 2C, where S represents the number of miles they drive the SUV, and C represents the number of miles that they drive the car. The family agrees to limit the total CO2 emissions to less than 600 pounds per month. So there's that word, less than 600 pounds per month. Recalling that the car emits 0.75 pounds of CO2 per mile, and the SUV emits 1.25 pounds of CO2 per mile, Jared writes the inequality 0.75C plus 1.25S is less than 600. So we've already wrote this inequality before in one of our previous lessons. Together, the two inequalities form a system of linear inequalities. S is greater than 2C, 0.75 C plus 1.25S is less than 600. Use what you have learned about solving linear inequalities with two variables to develop a strategy for solving systems of inequalities. Alright, so it says, why is the system of two inequalities above an accurate model of the conditions that Jared's family wants to satisfy? Well, why is this an accurate model? Well, we know that this inequality is going to give us the total pounds of CO2. So 0.75 C plus 1.25 S is less than 600. That's going to give us our total emissions. And then the other one, S, is greater than 2C. That's going to give us how much more the SUV emits than the car. So this is going to tell us how many more miles we drive the SUV than the car, and how much more we are emitting of CO2 if we have that. Now it says, how would the system change if Jared's family agrees to total emissions that are at most 600 pounds rather than less than 600 pounds? Well, for one, we're going to have 0.75 C plus 1.25 S. Instead of less than, it's going to be at most. So it would have to be less than or equal to 600. So that would change that inequality. This one probably wouldn't change at all. It could still be S is greater than 2C. So the only thing that it would change is that it could be equal to 600. Alright, now it wants us to graph these. So first I'm going to graph this inequality. Now we graphed this before, so we found our two maximum points how we did that was we took 600 divided by 0.75. So when we do that, we're going to find our car miles. The car miles were 800. And then we found our SUV by doing the same thing, 600 divided by 1.25. When we do that, we get 480. So 480 would be about there. Then we would connect those dots, and we have our first inequality. Almost. We have our line. This says less than 600, so everything underneath our line is our region that is less than 600. So this line is our 0.75c plus 1.25s is less than 600. Now when we graph this next one, s is greater than 2c. So we got to put in some points for this then and see what they could be. Well, if I put in, let's say, 100 for s, that means that 100 has to be greater than 2 times c. So c has to be, so it could be anything less than 100. So I'll say 50. So to get 50, it would have to be 2 times 25, which would give me a point of 25, 100. So I'll put a point there at 25, 100. That gets me right there. I know I'm going to start at 0 because I have no, so if I have s is greater than 2c, I have no b, so that would be like plus 0. Then I'm going up 2 every time. So like if I had 100 for car miles times 2, that would be 200. Or if I had 200 times 2, that would be 400. So 200 would be at 400. 400 would be at 800. So I have my graph going up like this. Now this is s is greater than 2c plus 0. So everything greater than that is going to be in this region. So if you notice, what just happened was that 2 of our regions combined, and we now have a region that's going to satisfy both of our inequalities. So where on the graph are the points that satisfy both equations? Well, it's in our region where both of our lines cross. Find 3 solution pairs for the system. Okay, well, if I go back, it looks like 0, 200 could be a solution to both systems. So I could write 0, 200. Looks like to me 100, 300 would work. And then it looks like maybe we could have 150, 400. So that's 3 points. You guys can come up with your own points if you want to. So it says, can Jared's family drive a total of 800 miles under these conditions? Well, could we ever get to 800 miles? Well, the highest I can go for car miles is 200. So if I go up to 200, I could go over to 400, which is 600. So no, this doesn't look like that's or what I could do. Highest I can go is 480, and the highest I can go is 200. 200 plus 480 would not be 800. So no, they cannot. Last one, I want you guys to try on your own now. Read the description here.